Hi, my name is Muhammad Qayyum Aziad bin Azwan. This experiment video is about the effect of heat treatment on the microstructure of steel. So basically there are 5 most common type of heat treatment, which are annealing, normalizing, spheroidizing, quenching or hardening, and tempering. As you can see, in this experiment, we use 5 different samples of heat-treated steel. The first one, we used a sample without heat treatment. Second one, with water quench. Third one, oil quench. Fourth one, normalizing. And the fifth one is annealing. So the first one, without heat treatment, so we don't do nothing to the steel. The second one is water quench, a process of heating sample to austenite and then cool rapidly. We heat the steel to 30 to 50 degree above upper critical temperature, and then we immerse in water quench bath. We use water because it has moderate cooling rate, so it will be different result. As you can see in the table below, the cooling rate on the material can be summarized. The properties, it is hard, strong and brittle. Microstructure should be molten side, grain size should be small. The advantage is because most efficient quenching media in commercial use where maximum hardness is required. The third one is oil quench. It is the same because it's quenching or hardening. We heat to 30 to 50 degree Celsius above upper critical temperature and then immerse in oil quench bath. We use oil because it has lower cooling rate and it should be different result. The properties, it will be soft, weak and ductile. Microstructure should be ferrite, pearlite or cementite. Grain size should be large. Advantage is because less cracking and distortion compared to water. Next, normalizing. We heat the steel above austenite temperature, either 55 to 80 degrees Celsius. After a few amount of time, it has been allowed for the alloy to completely transform to austenite, and then we remove from the furnace and cool it in air at room temperature. The purpose is because it has faster cooling, provides higher strength and hardness but lower ductility if compared to a full annealing. Higher strength and hardness material, it is to improve machinability and to refine grain by decreasing grain size and more uniform distribution. The last one is annealing. There are 2 types of annealing, full annealing and process annealing. Full annealing, we heat the steel above the austenite temperature, either 50 degree Celsius. Process annealing, we heat the steel below upper critical temperature about 500 to 600 Celsius. It is to cause recrystallization of a red phase. The full annealing is about 50 degrees Celsius to 40 degrees Celsius. So annealing, the purpose is to reduce hardness and brittleness, to alter microstructures so that desirable mechanical properties is achievable, to soften metals to improve machinability or firmability, to recrystallize cold work strain hardened metals. Next is sample preparation. We will do this on our experiment. There are 5 steps for sample preparation, which are cutting, molding, grinding, polishing and etching. The first one, cutting. So for my own procedure, I use woods to make an example to cutting the steel. As you can see in the small video, we actually use machine to cut the steel. I calculate the length of the words and then I cut using handsaw to a small size. In this experiment, I use a simple glove for protection, and I also wear glasses. I use hand glove and also wear glasses. I use hand glove and spectacles for protection. It is actually not a strong protection, but that is the procedure. The next one is molding. So I got this from somewhere. It is a sample. It is a real procedure of sample preparation. It is molding. I'm not sure how to mold because it needs heat and some chemical substance. We use phenolic powder to mold with the steel. As you can see, the mold is heated with steel and phenolic powder, and then it will become as you can see in the video. Next is grinding. Grinding, I use a sandpaper, 5 types of sandpaper with different roughness, from rough to less rough or soft. I use 600 CW. I use 120 CW, 400 CW, 600 CW, 800 CW, and 1000 CW. There are 5 of them. I buy at the hardware shop. So I grind the woods to make it softer and smooth. Next one is polishing. Polishing, I use a windscreen cleaner to polish the base of the woods, but I only use 1 layer. But the real one, we need a 3 layer with 3 concentration of chemical. The last one is etching. Etching, I use a video to show the process. We place it on a chemical, very high concentration chemical, in a few seconds, and then in a fume hood safety. After a few seconds, we wash the base, and then we close the fume hood. So this is an example by microscopic to observe microstructure produced. So that's all from me. Thank you.